Hello, I'm Chris Athanas. I'm a KMP developer. Tech Sport's coming out Tuesday to close up that bad boy. Today I'm going to be reviewing the Kotlin Code Reuse from this my new favorite Kotlin instructor. He's really clear, but he also does this thing. Let me make sure. There we go. He does this thing where he doesn't do any graphics. So I'm a very visual person, so I'm gonna be adding some graphics to his presentation and doing some commentary.
Almost 30 years ago, back before Java even hit version 1.0, the Gang of Four published a book that became a classic in our industry. It's Design Patterns, Elements of Reusable Object-Oriented Software. And in the introduction of this book, the authors stated the principle, favor object composition over class inheritance. And like all memorable quotes, I think the principle itself became way more popular than the context in which it was originally stated, and so a lot of developers have kind of held to that principle dogmatically without really weighing the advantages and disadvantages of each approach. So today, in this video, we're going to take time to understand inheritance and composition. We'll get a feel for the trade-offs involved, and then we're going to look at what I believe to be an underrated feature in Kotlin that can help change our perspective on it. So let's start with inheritance. Even if you're relatively new to software development, if you're using an object-oriented programming language, you almost certainly understand the idea of inheritance. Let's take a look at a simple code example, and we'll examine the characteristics that this design choice gives us.
I need to fix something real quick. All right.
This gives us. So here we've got a simple model for a vehicle, and it's responsible for keeping track of its speed, and that speed increases whenever we call the accelerate function here. And it also has this function named makeEngineSound. Remember in Kotlin that if we want to be able to extend a class, we have to explicitly state our intention by using the open modifier on the class and on the members that we want the subclasses to be able to override. So down here we have a class named racecar, and it's a subclass of vehicle, so that means it does everything that a vehicle does, but instead of making the default vehicle sound, it makes this sound here. Now racecar has a speed property and an accelerate function, even though we don't declare them in the body of this class. It inherits them from the vehicle class.
So basically he's setting up this. This is a little visual thing to help out what's going on here. So it's doing this race car here, and it's inheriting from a vehicle, and that should help.
And racecar is also a subtype of vehicle. So for example, a function that can only work with vehicle objects can still work with a racecar object. So to demonstrate that, let's move these lines down to their own function. I'm going to refactor this with the extract method in IntelliJ. I'm going to actually just use Control-Alt-M, and we'll call this new function drive, and we'll rename this to vehicle, and we'll change the type of this parameter to vehicle. And as we can see, everything compiles just fine. It's possible to pass a racecar object to a function that expects a vehicle because racecar is a subtype of vehicle. Awesome. Okay, we can run this and we'll see the output that we expect. It prints out the engine sound, and then after accelerating twice, the speed is 4.0. So what are the characteristics that we've noticed about inheritance here? Well, as we just saw, inheritance gives us a subtyping relationship between racecar and vehicle. So we can substitute a racecar anywhere that a vehicle is expected. And this increases flexibility because it gives us options. We can pass either a racecar or a vehicle where a vehicle object is expected. Another characteristic we see is that there's a relationship between these two classes, and it's declared statically. So we have this static reference to vehicle here. And because vehicle is a class rather than an interface, this means that every racecar object depends on the implementation of vehicle. So this characteristic decreases flexibility because racecar is stuck with a single implementation. However, this is advantageous for making the code more understandable. Like you can easily jump to the definition for a vehicle and see what its implementation is. So this characteristic has some trade-offs. Finally, the member functions and properties are pulled in automatically for us, which is pretty cool. So in other words, we don't have to declare speed or accelerate here in the subclass at all. We only included the one function that we wanted to override, so that's a +1 for convenience and for concise code. Now, as I mentioned at the beginning of this video, inheritance is only one way of designing our code. We can also use composition. So let's take the code that we've written so far and restructure it so that it uses composition instead.
Yeah, so when I first heard this composition versus inheritance, I was like, what are you guys talking about? Like, why is this even a thing?
Okay, since we don't want to use inheritance, the first thing we can do is remove this open keyword on the vehicle class and on this function here. When we do this, we get a couple of errors, and that's fine. That's what we're expecting. We're no longer able to extend it in the racecar class, so that's great. So let's remove the inheritance here. And we'll also remove the override keyword here. And then in the constructor, instead of accepting the acceleration, we'll just accept an actual vehicle object, making it a property of the racecar class. Now, when we construct a racecar down here, we'll need to pass a vehicle. So we'll just wrap that acceleration in a call to the vehicle constructor. The racecar doesn't have any definition for speed or accelerate, so we're going to need to add those members. And we'll just forward any requests for those members to the underlying object here. So we'll use a getter for speed so that we always get the latest value that way. And we'll forward the accelerate function as well. At this point, racecar has all the same properties and functions as vehicle, but we still have this error here. We can't pass it to a function that accepts a vehicle because with our updated design, racecar is no longer a subtype of vehicle. And since Kotlin is a statically typed language, we have to actually declare the subtype relationship. It's not good enough to simply have the same property and function signatures like you can do with other dynamically typed languages like Ruby. So the solution is to use an interface. Let's use IntelliJ's refactoring tools to do this one for us. I'm going to place the cursor up here. And I'm going to go to
Basically doing
refactor,
this.
introduce interface. I'm going to select all the members here. And we actually want the speed to be a read-only val. This is going to make it a var. So we'll just go ahead and create the code and change this to val. And then we need to declare that race car is a subtype of iVehicle and make sure that we add the override keywords on these three members. And finally, look for any parameters.
So I always got confused, like, why is it got to do this inherit versus implement? Because they want to make, when a programmer uses this word implements, it's because he's using an interface. That's all he's trying to indicate. It's like there's an interface that has all of these methods and variables that are going to be there defined, and we're implementing a concrete version or an actual in-memory version of that interface. So that's what that's indicating. And I do like this I on the front. Some programmers don't like this. Some Kotlin programmers don't like this. This came from like C#, but I really like it. I like putting the I on here on the front because it's an interface, right? It's some people in Java were using this a little bit here and there. Some Android developers are not used to seeing this. But it just makes it nice to know that, there's going to be, it's not just I'm not just extending a class. It's actually an interface that I'm implementing. And that's what that's all about. That's all it is.
Properties and variables that refer to the vehicle class, and we're going to update them to use the iVehicle interface instead. So here and here, just like that. Now, when making this change, we end up with kind of an awkward naming situation. We've got an interface named iVehicle and a class named vehicle. And some developers prefer to name the interface as the unadorned name, so just vehicle, and then they would name the class vehicle impl for vehicle implementation. And that's kind of awkward too. Sometimes I'll name the class something like simple vehicle or basic vehicle. But you know what? In this video, let's just go with it. Let's embrace the awkwardness, and we'll stick with iVehicle and vehicle. So we can run this code, and we can see that we'll get the same output as we had last time.
At least with this convention that he's establishing here, that that the vehicle and the iVehicle, which is which, right? There's no mystery.
So this code does the same thing as our inheritance code did, but it's a few lines longer. So what are the characteristics of this approach compared to the inheritance approach? Well, first, there's no subtype relationship between race car and vehicle. So we can't substitute a race car for a vehicle as we saw. We did introduce an interface though, so we can use that instead. So we might consider this a disadvantage that we had to create an additional type with iVehicle up here.
Yeah, so
now race car has no...
This is what he's talking about right here. We have a vehicle, and then a race car encloses the vehicle, right? That's the basic idea. That's it. That's the big idea. I'll let this keep going here.
No direct dependency on the vehicle class. It only has a dependency on the interface, iVehicle. So we're not actually coupled to the implementation of vehicle. And this one is a massive boost to flexibility. And I'll show you what I mean in just a minute. And then third, race car uses speed and accelerate from the interface, but we had to manually include them here by simply forwarding each one to the vehicle object. So they didn't come in automatically for us like they did with the inheritance approach. We had to add this boilerplate. So here, more boilerplate, more noise. Okay, now it's worth taking a moment to consider the benefits of having no static dependency on this vehicle class. So in our original code with the inheritance approach, we declared that dependency right here. And I hope you like that implementation because you're stuck with it. Every single instance of a race car is going to use that implementation of vehicle. So let's say that we were to introduce another kind of iVehicle called junker. And this junker is an iVehicle that just doesn't go anywhere. Its speed stays at 0 no matter how much you accelerate. So with our composition approach, we can just go down here and instantiate another race car using this junker, and everything just works. It won't budge because it's a junker.
So he's talking about doing this. So instead of having this vehicle here, he's got a junker. That's all he's talking about. And I guess you could have had another junker class that extends vehicle or iVehicle. Yeah, you do it the same way too. It's just one way or the other. This one is way more flexible because you can just swap things in and out at will. And this one is more. It's very. You're static. You're like you can't change it. It's very very difficult and brittle to change this type of thing here. And not just for like one or two, like if you have like 3 or 4 or 5 or 6 or 7, it becomes very difficult to manage that and just take out something in the middle when it's hooked up to all this other stuff. Versus this, is you could always use the race car separately, junker separately, vehicle. Everything could be separated out. That's the big idea.
Junker. And in fact, we can even change this out at runtime if we want. So instead of creating a second race car object, if we make this vehicle property public and mutable by changing it to var instead of val, then we can reassign it like this. And we have none of those options over here with this inheritance approach. We're stuck with
Right.
nothing but the one
Same
vehicle class.
thing here.
And so that's a lot of flexibility that we get with composition. So on the whole, composition is a lot more flexible than inheritance. Flexible code can be harder to understand though, because there are a lot more objects and types that are involved. So if you don't need all of this flexibility, then it's totally fine to just use inheritance. When we say favor object composition over class inheritance, it doesn't mean that you should never use inheritance.
Right.
In fact, the design patterns book points out that they both have their advantages and disadvantages, and they can work together. So each project is unique. Some characteristics will be more valuable in certain projects than in other projects. And it's your job as a developer to evaluate those characteristics and determine the design that's most appropriate for your app. And that's the hard work of being a software engineer.
I would say that if you're going to be extending your classes more than 2, start thinking about using composition. I'm gonna leave the link to this video, the rest of so you can watch the rest of it. But that's the main points I wanted to bring across. That's the stuff that confused me. Is what is this all about? And now you see what I'm talking about. All right, give me a like and subscribe, and let me see what's going on with this thing. Okay, I'm having issues. If you like and subscribe, I'll talk to you soon.